Hello, learners. Welcome back to Wizartist. Today, we are going to be studying Class 8 Physics, Chapter number 13, Light. Light makes things visible. This is a universal truth. This means that it is because of light that we can see the world around us. To understand this, let us go in a dark room. And if there are any non-luminous objects in this room, we will not be able to see them. Non-luminous objects means those objects which do not emit their own light. Now, bring a light-emitting object in the room, that is, a luminous object. Here, it can be a torch or a ceiling bulb. The light emitted by these objects strikes any non-luminous object in the room, and that light reflects back or bounces back from that object to our eyes, and thus our eyes can perceive that light and see that object. This phenomenon of the light bouncing from the object and entering our eyes makes things visible to us. Which brings us to the conclusion that light helps us see non-luminous things or everything around us in general. Now let's understand about reflection. We know that light always travels in a straight line, as we have studied in earlier classes. But when a ray of light strikes against a polished or shiny surface like a mirror, so it's initially traveling in a straight line. But once it has struck this mirror, the light changes its direction and moves ahead in that changed direction. This is the changed direction. This phenomenon of a light ray changing its direction because of it striking against a shiny surface is called reflection. So when we see our reflections in a mirror like this, it is the bounced back or reflected light that we perceive as our reflections. Now let us understand in the terms of physics about reflection in more detail, that is, the components of this reflection. Here is a mirror. Let us draw an imaginary line through the middle of the mirror. When we throw light on it, the path of the light is shown by this line, and this line is called the incident ray, which is inciting or striking the mirror. This point, where the incident ray and the imaginary vertical line intersect each other, is called the point of incidence. Now let us draw a perpendicular line against this vertical imaginary line passing through the point of incidence. Perpendicular means that it has an angle of 90 degrees in between. This perpendicular horizontal line is called the normal, and the angle that the incident ray and the normal makes is called the angle of incidence. When this incident ray strikes the polished surface, it gets reflected, and the path of that reflected light is called the reflected ray. The angle that the reflected ray makes with the normal is called the angle of reflection. Now, when we are trying to solve numericals, we do not draw an elaborate image. Instead, we draw a sophisticated diagram. To draw the diagram, we draw a vertical line with these slanting lines on one side. These slanting lines show that the non-reflecting side is present over here, and the other side is the reflecting side where the mirror's face is located. Then we draw this perpendicular horizontal line, which has the angle of 90 degrees and is called the normal. Then we draw the incident ray, which has this direction. The angle between the normal and the incident ray is I. Then we have the reflected ray with this direction. And the angle between the normal and this reflected ray is represented by R. I represents angle of incidence and R represents angle of reflection. And let's not forget the point of incidence. Now, point of incidence is not very important in terms of labeling a diagram, but it is very important to identify the position of the normal. Based on these diagrams, we can understand a few laws of reflection that every phenomenon of reflection follows. The first one is that the angle of incidence, or I, and the angle of reflection, or R, is always equal. In every condition, if reflection is occurring, these two angles will be equal. Mathematically, we can write this angle symbol, and R is equal to the symbol of angle and I. R represents angle of reflection and I represents the angle of incidence. And these two are always equal. The second law is that the reflected ray, the incidence, and normal always lie on the same plane. What this means is that if you were to put the phenomenon of reflection on a paper, which is a two-dimensional sheet, and have a look at it in one dimension, that is laterally. Laterally, that means you view it from this side, so you only see a line like this, right? Then if you were to view it like this, the point of incidence, any point on the incident ray and any point on the reflected ray all would lie on this line itself. This means these points all would lie on the paper itself. That is, it is in two dimension. It will not have a z coordinate. That is, the whole phenomenon of reflection lies only on the xy plane. So if you were to make the 3D plane like this, with this being the x-axis, this is z-axis, and this is y-axis, the reflection would only be on this side and it would have no relation with the z-axis. So the z-axis is basically non-existent for the phenomenon of reflection. You will understand more about the xy plane in coordinate geometry. Next, we have the types of reflection, which are diffused and regular reflection. In diffused reflection, the surface through which light is reflected is irregular. Irregular means up and down. It's not like this, straight, simple, smooth. Instead, it is up and down, bouncy, bumpy. All in all, not regular. So in this case, the incident rays are parallel, but the reflected ones are not parallel. Parallel incident rays, but the reflected rays are not parallel. Does this mean that they do not follow the laws of reflection, especially the first one? Well, that is not true. Because even if it's apparent that the lines do not follow the laws of reflection, if you observe closely with each pair of incident and reflected ray, it does follow the first law of reflection. Let's understand that better. So if you were to look at a pair of incident and reflected ray like this, and then draw a normal through them, the angle, that is this incident angle and reflected angle, are actually equal. Both of these angles are equal. Same with the other pair. Let's draw a normal over here, and then this angle and this angle are equal. Now, if you're wondering how are we drawing this normal, because this definitely is not 90 degrees with this surface, well, that's not true. If you look closely, this surface is like this. So the normal will be drawn like this over here with a 90 degree, and this part will not be considered. So it doesn't need to be 90 degrees with the bottom surface, but with the surface where the light is reflected, which is this part. Okay. And the last pair, if you have a look, it also has the angles, equal angles, and therefore it follows laws of reflection. Both the laws of reflection are followed even if it is not apparent in one's view. let's understand the next type, which is regular reflection. Over here, light reflects from a regular or smooth surface where the incident rays are parallel as well as the reflected rays, and of course, they follow the law of reflection. This and this angle are equal, and this angles are also equal. Now let's understand multiple reflections. This means that if you were to see your reflection in a mirror and then place another mirror behind, there will be multiple reflections, more than one reflections. That is due to the two plane mirrors being used simultaneously, which results in multiple images. Such activities show that reflected light can be reflected again. That is, if a light is reflected once, this light ray is reflected once, then it can be reflected again. Right, so this is a simple rough diagram I've drawn. This is a light ray and it has been reflected by this mirror once, but this means that it can also be reflected again. So this is another mirror over here and it is reflected again. We can have another example where these two perpendicular mirrors and a coin is placed in the middle of them. And because of this, the images that are formed are multiple images of the coin. Why? Because there is multiple reflection. So basically, the coin is reflecting, the light of the coin is reflecting with this mirror, then this mirror, and then the reflection is also happening between the two mirrors themselves. Right. And because of this, there are three reflections in total, which is why we get three images as well, right? We have also observed something similar in a periscope, which is an activity that we have already done in our seventh grade. Then we have the idea of a kaleidoscope, which is an example of multiple reflections, where you have a prism-like structure over here and mirrors on the three sides. Over here, I've just represented the presence of mirror with the word itself, so you can imagine how the mirrors are placed. If you were to place any colorful object in the kaleidoscope and see it through a peephole that is present in the device, you will notice beautiful patterns forming because of multiple reflection. So what exactly is the reflection that is happening? So we have the mirror on this face, on the further face over here, and also on the base face. So the object reflects with all three faces, right, obviously. So these arrows basically mean that reflection is happening. And the three mirrors also reflect among each other. So these two mirrors will reflect with each other, and these two will as well. So you can see there's a whole mess, chaos. There's a lot of multiple reflection happening. Like if you were to place two mirrors like this, the lights between these mirrors will be continuously bouncing back and forth, back and forth. This back and forth and multiple reflection is exactly what forms such beautiful patterns. The image that is formed by a plane mirror has some properties, and let's study them. We already know what a plane mirror is. So, coming on to the properties, if we assume this to be the object placed in front of the plane mirror, then the image that will be formed will be erect. That is, it will not be like this. Instead, it will be straight. So, if the object is straight like this, then the image formed will also be straight. Okay, so simple quick doubt clearing. What is the difference between an object and an image? So the thing in the real world that you're placing in front of the mirror is called the object, right? So this is the object that you're placing. And then when it's reflected, when the light is reflected and the thing that we see, the reflection that we see is called the image. Right. So the thing that we're placing in front of the mirror is the object and the reflection that we are perceiving in the mirror. So it's not basically, this is the reflection, but in sense, it's basically present over here. So this is the image. Okay. So quick clearing of what is an object and an image. So, so the object, this is the object that we're replacing, and now let's understand how the image is. So the image is erect, but it's not the exact duplicate. It is flipped horizontally. and that is called laterally inverted. The image is laterally inverted, that is flipped horizontally. So if the object placed is like this, the image will be flipped, that is like this. But it will have the same size. If this object, suppose, is 1 centimeter tall, the image that is formed, this is the image, will also be of 1 centimeter. If this object has a length of say 2 centimeter, then the image will also have a length of 2 centimeter only. It's also at the same distance. That means if the object is placed 10 centimeter from the mirror, then the image will also be 10 centimeter from the mirror, behind the mirror basically. Object 10 centimeter in front of the mirror and the image 10 centimeter behind the mirror. And the image that is formed is virtual. We have already learned what virtual images mean in our earlier classes. Simply, it means an image that cannot be obtained on a screen. And on the contrary, what do we call images that can be obtained on a screen? Yes, a real image can be obtained on a screen, but real images are not formed by plane mirrors. Plane mirrors form virtual images. Next, we have the concept of white light. The sun is an example of white light. When we pass the rays of the sun through a glass prism, the 7 colors of the rainbow are obtained. This means that the white light of the sun, is dispersed. Dispersion of light is the phenomena where a light is separated or dispersed into its constituent colors. Constituent colors means the colors that come together to form the main light. So if you simply have a look at the light, it will seem white, but in reality is formed by vibgyor, that is violet, indigo, blue, green, yellow, orange, and red. And these are the colors that come out refracted from the prism. Similar thing happens during rain. When the sun comes up during rain, there is a rainbow formed. Why does this happen? Because the raindrops act as a prism for the sun rays and therefore rainbow is formed. Now let's understand the beautiful organ of the human body, that is the human eye, which helps us see and understand the world around us. This is how the human eye looks from the outside in the exterior, and this is how it looks in the interior. It is an almost spherical shaped eyeball, isn't it? Let's understand the structure of the eye in more detail. From the exterior, we can see that there are eyelids or eyelashes that protect the eye from external pathogen and dusts. Basically, they help us blink continuously, and that helps protect our eyes from dust. The middle part, the dark part, you can notice is called the pupil, and the colored part outside is called the iris. The iris is the color of the eye that we see. So when we say that someone has a green eye, it basically means that the color of their iris is green in color.
The white area surrounding the pupil is called the sclera.
Now if we have a look at the internal eyeball, we have the sclerat. Then we have a transparent layer covering the entire eyeball called the cornea. The main purpose of both sclera and cornea is to protect our eye from external damage. This black dot over here is the pupil, which controls the amount of light entering the eye. This white disc over here is the eye lens or the crystalline lens. These are the ciliary muscles, which controls the size of the lens to adjust the size of the lens depending on the distance of the object that we are trying to view. Over here at the back, there is a retina, which is a light sensitive part. And then there is the optic nerve, which transmits the images to the brain for interpretation. Now let's understand the functioning of the eye in more detail. So the light is coming from here, and the pupil controls the amount of light entering with the help of the iris. So the iris is also muscular, which controls the size of the pupil. If there is a lot of light, let this be the original size of the pupil. If there is a lot of light, the pupil contracts, that is, it becomes small. A lot of light, it becomes small. Why? So that large amount of light does not enter the eye and thus does not damage the inner part. On the other hand, if it is a dark room, dim room with less light, the pupil's size increases. It becomes bigger, slightly big, so that the eye can gain maximum amount of light. So more light will enter through a bigger pupil, right? So maximum amount of light can be gained by the eye so that the objects can be viewed even in the dark. Next is the lens, which forms an image of the light entering from the pupil onto the retina. An image is being projected on a screen. This means it's a real image. Then there is the retina, as I said, which is a light sensitive part where this real image is converted into messages that can be transmitted to the brain. These images are detected by two light sensitive cells, cones and rods. Cones are receptors responsible for bright, colorful light, especially during the daytime, and rods are responsible for dim black, white, grayscale light, especially during the night time. Then we have the optic nerve, which transmits this message from the retina to the brain for further interpretation. Now, if you notice, these optic nerves and this retina, they have an intersecting point. This junction of the optic nerves and the retina is called the blind spot. Why is it called so? Because this intersection or this junction is absent of any sensory cells. Any rods and cones are not present in this spot. That is, if any light falls onto this blind spot, our eye will not be able to perceive it or interpret it. Persistence of vision is that the image of an object formed on our retina will stay on the retina for a very short amount of time, which is precisely around 1 upon 16th of a second, which is a very small time. Right. So if an image is formed on the retina, that image will stay over there for 1 upon 16th of a second. That is, how long is 1 second? Then divide that by 16. That's short. It's a pretty small amount of time. So we can say or conclude from this that if images flicker at a rate of 16 or more per second, that is, in 1 second, if more than 16 images are put in front of our eyes, one after the other, our eyes will perceive it as moving. That's exactly what happens in motion pictures or movies, which is usually 30 or 60 images constantly flickering in front of our eyes in 1 second. And because of this persistence of vision, our eyes will not be able to detect these continuous 30 to 60 images individually, but instead detect it as a motion. So, movies and flip books are examples of this concept. Vision range. We know that our eyes can see images close as well as far easily. This is because of the increase or decrease of the size of our lens by the ciliary muscle. But it also has a range. The closest object that we can clearly view is 25 centimeters away, and the furthest is at infinity. This range from 25 centimeters to infinity is called the range of vision of a healthy eye, or vision range of a healthy eye. But there are some defects which causes changes in this range. If the range becomes greater than 25 centimeter, then the eye cannot view objects too close and thus has to be corrected with a convex lens. So if we have to view any objects over here, that is in the proximity of 25 centimeters, because of this defect, the eye won't be able to view that. And if we want to view that because it's important, like to read paper, etc., we use convex lens. This defect is called hypermetropia, and thus the vision range of more than 25 centimeter to infinity is called the Vision range of hypermetropic eye. Hypermetropic eye means the eye suffering from hypermetropia. On the contrast, if the range becomes less than infinity, the eye cannot see objects very far away clearly. And this defect is corrected with a concave lens. So, suppose an object is placed over here. It is at infinity. A healthy eye will be able to see it because the range of a healthy eye is infinity. But an eye with this defect will not be able to view it clearly. It appears as blurry. To view that object clearly, this eye will need specs with concave lens. This defect is called myopia, and the vision range of myopic eyes is from 25 centimeters to less than infinity. An individual can face both these defects, that is, hypermetropia and myopia. And in this case, it is corrected by a bifocal lens, which is a mixture of both concave and convex lens. There is also another defect that usually happens in old age. Just observe these lens and this iris of the two eyes. Due to old age, this may become foggy. And because the lens becomes foggy, the vision is obstructed and it can even be lost. This is called cataract, and it can be easily surgically cured by inserting an artificial lens through operation. New technologies have made this procedure a lot safer and also more efficient. We should take care of our eyes because they are very important. We should wear specs if we are advised so. There are a lot of people who do not do so because they think specs don't look good on them. But your looks are far less important than your eyes, so do wear your specs if needed. Use proper lighting wherever required, wherein the light should be neither too dim nor too bright. Appropriate lighting makes your eyes well. Avoid looking directly at the sun because it is a very bright source of light and it can cause pretty fatal damage to your eyes. Not rub your eyes. If dust has entered in them, instead, wash it with clean water, or if it persists, you can use safe eye drops. Read out normal distance, that is, at 25 centimeter or more. It should not be too close nor too far because it can give strain to your eyes, which can lead to eye defects. Also, the root to every issue is an unbalanced nutrition. So make sure you eat foods rich in vitamin A, like carrots, spinach, and milk to keep your eyes healthy. Visual impairment means limited or no vision at all. This can be since birth, because of a disease, or because of an injury. In such cases, people identify things by touching them, listening to the voices and sounds around them very carefully. Because of this, their other senses are developed more sharply compared to people without any visual impairment. Now let's understand about Braille System, which is a reading and writing system for visually impaired people. It was invented by Louis Braille, who himself was a visually challenged person. It contains 63 dot patterns, which has been adopted since 1932, and these dot patterns can be memorized by blind people. These patterns are embossed on special sheets called Braille sheets. And these dots of patterns are slightly raised so that they can be easily felt or touched by the visually challenged people and thus understood. You must have noticed such raised dots on elevator buttons, TV remotes, etc. This embossment can be done through hand or even by machines. Typewriters and printers for the same have been developed to provide widespread opportunities. And that was the last topic for this chapter. Coming on to homework, which is a simple fill in the blanks activity from your NCERT. The first question is related to the property of images formed by plane mirrors. And the second one is also related to the same, that is lateral inversion. For the second question, you can perform the same activity in front of a mirror to understand the blanks, which occurs when, and if you practice a few times, you will be able to do it without any external help. The third one is something that I have already discussed, so it should be pretty simple. And the last one is a more or less question. That is, you have to choose between more or less. That is, do night birds have more cones or less cones than rods? This is related to which receptor is needed in the night for dim light. I have explained that, so you can quickly go back if you have not heard that carefully, because these are very basic and important concepts. And that was it for this video. Thank you for watching. I hope all the topics of this chapter have become very clear to you. You can find the link to other Class 8 science videos in the description. If you have any queries, you can ask them in the comments below. And that is it for today. Bye bye, until next time.